Hello, this lesson is about quadratic functions and how to graph using the multiplier of a in front of it, using transformations and not having to put points in. All right, so here you can see that we have a number in front. We have a 2 in front. So what I'm going to do is graph the parent function first. So for a parent function, we start at 0, 0, and then it goes 1, 1. Same as the other side. And then we go 2, 4. And then we go 3, 9. And then the other side is, okay, I'm not sure what. There it goes. Okay. So we graph them by just knowing their points and the shape of it. 1, 1, 2, 4, 3, 8. So when you have an a in front that is bigger than 1, we know it's going to get thinner. So we're going to take that multiplier, and that's going to change all our y values to be taller or higher. So our multiplier, I'm going to put it for 2. So this is not a table, a normal table that we're used to. This is going to show us how to change these points. So we're multiplying 2. Usually it's 1, 1, 2, 1, 1, 2, 4, and then 9. Okay, these are the y values of them, of that moving here, right? That's the 1, this is the 4, and this is the 9. Now we're multiplying it by 2. So instead of going up by 1, you're going to have to go by 2. 2 times 4 is 8, and then 2 times 9 is 18, which is not going to fit on the paper. So let me show you how that works. So your x values are always going to stay. You're going 1 to the right, but instead of going up 1, you are now going up 2. You're still going 2 to the right, but instead of going up 4, you're now going up 8. It's this number now. And for 3, instead of 9, you're going to go up 18, which would somewhere be up there. And it's going to be like that. Okay. And so this number 2, some students think it's slope, that you're going to just go up 2 over 1 every time, and that's not true, because the distance between the points get further away, right? It's not the same distance. All right, so let's look at this. So we can see that I'm moving it 7 up. I can see this is going to reflect it down. And then I have that 4 as a multiplier. So my 4 is a multiplier, so it's 1, 4, 9. Those numbers never change. So, and you're multiplying 4. So now you're going to move it 4, 16, and 36. Now this one, I'm not going to do. So from your origin here, you're going to move up 7. 1, 2, 3, 4, 5, 6, 7. And I know I'm going to go down. So it's 1 to the right, and now I know it's 4 down. And we're going down because of the negative. 1, 2, 3, 4. And then for this next one, it's 2 to the right, and now it's going to be 16, because 4 times 4 is 16. So that's 7, right? So we're at 7, so from here, 7. So it's 1, 2, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Let's see here. And so it's very thin, very skinny. So we can see as that multiplier gets bigger and bigger, and just this number, right? That negative actually flips upside down. That number is making it thinner and thinner and thinner. So if we get to 100, what do you think? If this multiplier, the A was 100, what do you think the graph would look like? Okay. So these are for numbers for A bigger than 1. But what if you have a fraction in front? So now my multiplier is a half. So usually, again, it's 1, 4, 9. And so you have to multiply by half. So now we're going to shift it up a half, 2, and 9.5. Yes, that's 4.5. So we can see here that this is telling us I'm moving it to the right. 1, 2, 3. So usually it's 1, 1, right? But instead of 1, now we're going half because we're only going half as much up. So it's here. So I think I'm going to put more points. Okay. And then let's do the next one. So 2 now used to be 4, but we had to multiply it by half. So now it's half. Sorry. So it's half of 4, which is 2. And 2. Okay. So let's do this next one. So it is now 9 over 2, which is 4.5. So it's 1, 2, 3. 1, 2, 3, 4.5. So this is 1, 2, 3. 1, 2, 3, 4.5. Remember, it's not going to go straight up like this. It's going out slightly. So it's a little wider than a regular parent graph. All right, so let's look at this one. This one's interesting. The multiplier is 2/3. Now here it's going to show us our vertex. Our vertex is going to be -4, 5, -5, because we are going 4 to the left and 5 down. So my multiplier, and yes, sometimes you're going to have crazy fractions, and that's okay. Times 1, that's going to be 2/3. And 2/3 times 4, that's going to be 8/3, which is approximately 2 and 2/3. And then, or is, that is approximately. So that's 2 and 2.67. And then 9. 3 goes into 9 3 times, so that's 6. All right, so this one's a little bit harder. See if I can make my pen a little smaller. Okay, so 2/3 for this would be right underneath the 1. Let's see if I can get that right there. Oop, yeah. And then for the next one, it's going to be 2 and then 2/3. So 1, 2 and 2/3. So it's about here. And I really like this next one that's 6 because it's right on point. 1, 2, 3. 1, 2, 3, 4, 5, 6. 1, 2, 3. 1, 2, 3, 4, 5, 6. Here we go. So if the A is less than 1, it's going to get wider. And the smaller the fraction or decimal, the wider it would be. Like think about like 1 over a million. What will that look like? These are not points. This is just your movement, right? Your movement of your y going from the vertex up. All right, so I hope this helps. And again, this is how I graph parabolas. It's much quicker than trying to put in numbers and x values, especially with fractions, and especially for problems like this, where you have the h and the k and an a. So here is a summary of how A, H, and K change and transform your parabola, how it moves the location as well as how it changes its shape. All right, hope this video helps, class. Thanks for watching. Bye.